Hello students, let's discuss the next topic of science and technology, that is nanotechnology. Nanotechnology is also part of your GS paper 3. As I have already told you, in science and technology section, it has been explicitly mentioned. So students, it is a very important topic. In the past previous year questions, if I tell you about prelims or mains, in both ways UPSC has asked question regarding nanotechnology, and it is being, you can say, upbringing field, and a very much in perspective of the India's growth as well. Nanotechnology can be one of the potential areas where India can grow. So not just with respect to science and technology, you must also read this topic with respect to economic aspect of the future of the country. Then right, for example, if we want to be a trillion economy, 5 trillion economy, then what steps we must take. So this is one of the steps, that in this particular area is still can be a very much potential area where research can happen. Then with respect to international relations also, this topic is important, because we should have collaborations throughout the world and the countries which are dominant players in the field of nanotechnology. This could be another way of expressing this same point as an example in one of your other topics as well. Then with respect to essay, science and technology, anyways, this topic can be useful to you for future applications. Then students, important aspect is also there, that what exactly UPSC is asking you about nanotechnology. See, it is actually the application part which is the main focus for UPSC. It is not expected out of you that you will do PhD in this particular topic. It is not expected, and we will not do it. We are not going to go into that much micro level of nanotechnology where the technical aspects are too much that we are not able to understand and express it in the exam. Whatever is the requirement of the exam, we will limit ourselves to that part, and do not go into much detail, because students do graduation and post graduation in the subjects, and hardly within 2 to 3 hours you will be able to even you will be able to express this topic in itself. But there are limited words that are required in UPSC mains exam, and there are limited questions that are asked in previous years with respect to nanotechnology topic. But still, whatever questions that were asked, they were mostly concentrated towards the application part and understanding the basics of nanotechnology, the basics. So if I talk about this term and if I try to define this term, students, how can you define it? When I say nanotechnology, so what does technology means? Technology simply means that you want to create some kind of product, you want to make some kind of a design, and this product and design, using the technical aspects, you want to do this so that human welfare can happen, right? And if we add nano word ahead of technology, or add these two terms together, then nano means, it means a very small amount or a very small particle. We are talking about atom level, we are talking about molecule level, in fact way below than atom and molecule level. So students, nano means, if I express what is nanotechnology, then we can take this example. Actually 1 meter is actually 100 centimeter, and when you want to write 1 centimeter, that means 1 upon 100 meter. So that means it would be 10 to the power minus 2 meter. So you understood this term. See, 1 centimeter in itself is so small, and if I want to express 10 to the power minus 9 level, that means 1 nanometer, you express it like this, will be equal to 1 upon 9 times you have to add 0, and then that is how 10 to the power minus 9 meter value will come. So you can see that you cannot see these particular particles through your naked eyes. This is micrometer, and mu is the symbol, that means 10 to the power minus 6 meter. So nanometer is much smaller than micrometer also, right? So let's define this term once. Define this word here. Nanotechnology is basically the manipulation of matter at a molecular or atomic level in order to produce novel materials. Novel means new forms of materials and devices with new extraordinary properties. So let's explain this particular aspect. What happens is when you talk about elements like matter at a macro level, they show some physical property and chemical property, but when you take the atoms, when you take the molecules and you go at the very small particle level, that means nano level, and when you make so much small pieces that you are going to the nano level, their physical properties and chemical properties, they change and they attain some kind of extraordinary properties which they do not have when we were seeing these elements in macro form. Until unless I give you example, you will not be convinced. So let's take this example of a bandage. A bandage is being used for curing the burns, but when I say this particular bandage has silver nanoparticles, it becomes easier to cure the burn. So silver, there are silver utensils that we have read about in the history, and in fact some people use it. Silver jewelry is there, but does silver has that property of curing your burns, the skin wherever it has burned? No. But when we take atom of silver, Ag is a symbol of silver in chemistry. This is how you represent silver. If we take it at an atom level, if we take molecule or atoms of silver and we see that they possess some kind of ability where they can be useful in curing the skin. So this is one example where how macro elements may not be that much useful, they do not show such property, but later if we divide them or make them to a micro or a nano level scale, they depict some kind of extraordinary properties. There is a change in physical and chemical properties, reactive properties. Next example is nano lasers. If we use such nano lasers in optical communication, it is observed after research that the transfer of large data can be done rapidly. This simply means, students, that optical communication, you know, the data, the technology is going at a next level from 3G to 4G to 4G to 5G in communication. We'll definitely discuss that part as well. But you see, optical fibers are there, and with the display of the optical fibers, the internet speed has increased. And if you are in urban areas, definitely you would have observed this, and this speed can also be increased further using nano lasers. So definitely these lasers are showing some extraordinary properties where they are exploited for this application. Okay, so this is another example. So how you are going to define nanotechnology? You would say nanotechnology is some kind of a design or production or its application of structure, maybe devices and systems where manipulation of the size and shape is happening at a nanometer scale. And why is it happening? It is happening because whenever any kind of a material at atomic or molecular level is seen and modified, it is being seen that there is some kind of useful properties that are being generated, and nanotechnology thus involves this kind of ability to control individual atoms and molecules, and henceforth they can be exploited for many kinds of applications. We will read the applications in subsequent slides. Next, we need to discuss what kind of approach is there while dealing with nanotechnological materials. So there are two types of approaches, students. One approach is called as bottom up approach, and second one is called as top down approach. Okay, so let's define first what is bottom up approach. Bottom up approach means that larger structure are built or grown atom by atom or molecule by molecule. So what we are trying to do is bottom up approach, means we are trying to make such kind of a nanomaterial using atoms, and then we are combining these atoms, or maybe molecules, we are combining these molecules, and henceforth we are making a larger structure. So such kind of a structure, if such kind of a design, such kind of a product is made out of the bottom up approach, means atom by atom we are doing it. But there can also be top down approach. In the top down approach we can define it when bulk of material, or you can say macro material, is gradually reduced in size to nanoscale. So there is another way. That let us suppose we have a proper matter at a macro level, and you start dividing it. Once you start dividing it, you make it to a nano level, and you make it till the nano level, and then utilizing it, and applicable further applications are being taken care of. So this is another way. Generally we can say, generally it is only the bottom up approach which is being mostly used in research, and particularly applied research, where different applications are seeing, in comparison to top down approach. But I have discussed both the approaches, whether you make larger design using small atom by atom, bottom up approach, top down having a macro matter, and you're dividing it and making it to the nanoscale. It's very simple, right? Now let us go into bit detail that why such properties are being changed at the micro level or nano level. So you need to understand one term, that is quantum size effect. You know, physics is at a classical level, then it is at quantum level. So quantum size effect, it describes the physics of electron properties in solids with great reduction of particle size. So what is basically quantum size effect? It is just describing physics, as I have written, it is just describing physics of electron properties. So you know, in an atom there is a nucleus, within the nucleus there is proton plus neutron. And what about electrons? Electrons are again charged particles that reside in the circular orbits around the nucleus. So electrons are revolving around the nucleus in an atom, and within the nucleus there are protons and neutrons. Protons are positively charged particles and electrons are negatively charged. Okay, and it is because of these electron properties in solids, the reduction with the particle size, there is a change in the basic physics, basic properties of the particular atom, and this is what quantum size effect is all about. You can further explain it that such changes in it can be witnessed, such changes can be witnessed because quantum size effect is being shown where reducing any particle, any material from macro scale to nanoscale happens, there is sudden change in the properties of these materials. But now again, until and unless I give you some examples, it will be difficult for you to understand. Now let us take some examples. One such example is that let us suppose some particle, some material is opaque, When we talk about the macro level, it is opaque in nature, but when we take it to the nano level, it becomes transparent. So now, as I've mentioned it earlier, there is some kind of sudden change in the properties of the material. So you can see that the material is becoming transparent now. The example to this particular change is copper. So this happens with copper, and copper atoms, they are transparent actually when it comes to nano level. Second example is basically of inert materials. Inert materials means that they are very less reactive, and they act as a catalyst. But when you take these particular particles at a nano level, they become highly reactive. And one such example here is platinum. So you see there's a change. Third example here, we can say that stable material. A material which is very much stable, it can become combustible. That means it can easily combustible. It may easily catch fire, it becomes combustible. For example, here we can talk about aluminium. What is the property of aluminium? That it is generally at a macro level, it is very much stable, but at a nano level, it is combustible material. Fourth example, there is a possibility that a material is solid at room temperature when it is acting seen in a macro level. But when it comes to nano level, the particular element, the particular atom, molecule, it may turn into liquid. And one example of this particular change is gold. So you see how am I giving you example, and what is actually the quantum size effect. The effect that has been seen because of the change in the properties, the change in the electrons, the way they are moving in the solids is the property where we can see the sudden change in the characteristic, the physical and chemical characteristic. Fifth example is also there. There can be insulators that may turn into basically conductors, and this may happen in the case of silicon. This is another example, and now we will be exploiting these properties for our applications. Okay, so it's a very simple topic, topic to understand if you have quoted various examples, right? Until unless you quote examples, you have quoted some examples here, it becomes easier for you to understand. Until unless you quote the examples, it becomes so difficult for you to understand the topic. Now let us discuss the history of the nanotechnology, how this particular field emerged. It was actually in 1959 when first theory was given by regarding nanotechnology was given by Dr. Richard Feynman, and later on in 1981 Eric Drexler, he wrote his paper means such kind of a publication where he explained about molecular nanotechnology. And then from here on the research in this field, it emerged at a very faster rate. However, in 1981 there was another major discovery of fullerenes. So I will explain here what are fullerenes. Its discovery is been seen very much remarkable in the field of material sciences. So actually what these fullerenes are all about, these are actually carbon made substance. So number of carbon atoms, they join together to make such a structure. These structures are basically spherical in shape. They can be of different shape, but one such example where I want to share with you, it is C60 fullerene. So many types of fullerenes are there. C20 is there, C60 is there, C200 is there, but C60 is one of the best examples and most commonly used example. C60, it stands for that there are 60 atoms. There are 60 atoms of carbon that are making a structure, and this structure is basically spherical, dome shaped structure. And this structure, the another name for such structure is Buckminster Fullerene. Another name for such a structure is basically buckyballs. So why the name Buckminster has been given? Actually, Buckminster, this person was a basically architect, and this person, he made a design of a building like a dome shaped structure. And since the discovery of the fullerenes were also like in spherical hollow structure and dome shaped, it named after the architect Buckminster. Never ever think that Buckminster is the person who identified fullerenes or discovered it. No, it was a name of the architect who was famous for its dome structure. That is why the structure name has been given, fullerene structure name has been given Buckminster Fullerene, and it is the most common type. It is C60. So students, basically these are pentagons and hexagonal rings, and this particular structure I am talking about, this particular structure is just like a football. So I'll make the structure. It is made up of pentagon and hexagon as I have written. So this structure is basically a hexagonal ring. It is made up of 6 carbons. Now you will wonder where the 6 carbons are. This is carbon number 1, this is carbon 2, this is 3, this is 4, this is 5, and this is 6. And these carbon atoms are bonded. So these particular green lines are the bond. So this is carbon, this is another carbon, and there is a bond in between. So you also express in chemistry something like this. So this is how you express in chemistry a molecular structure. So if I am making some dot, this is dot model. So the full structure is somewhat like this, that this is a hexagonal ring. With the hexagonal ring there is a pentagonal ring, and then near to the pentagonal ring there is another hexagonal ring, and similarly here, and similarly here. And now you complete this structure. If you complete this structure, it will be circular football like structure. So I hope now you understood it. This is Buckminster Fullerene, very important material. I'll tell you why. The basic features because of which this structure is very much important. The particular characteristics of this particular structure is high tensile strength. So it is used for its or known for its high tensile strength. Then it is allotrope of carbon. Now you would ask me, sir, what does allotrope mean? So students, basically allotrope means any kind of chemical compound having different forms, two or more than two different forms, physical forms. So here these particular structures will be called as allotropes, and the behavior will be called as allotrophy. So this is basically chemistry, in the chemistry it is a technical term, allotrophy. Allotrophy means we are taking example here of carbon, right? So allotropes of carbon, what are the allotropes of carbon? There are different structures present made up of the chemical compound carbon. One such example is fullerenes. Another example is graphene. Next example is carbon nanotubes. Then there is graphite, there is diamond. These all are the examples of allotropes of carbon. So UPSC has already asked a question regarding carbon nanotubes. Since this question has came up already, we need to learn about other allotropes of carbon as well. And in nanotechnology, what we are trying to do, we are trying to gain the properties of such allotropes of carbon and applying them and making good applications out of it, right? So here if I tell you some applications of fullerene, so applications of fullerenes, some applications are: first, it can be used in medical field where the drug delivery, they can be useful in drug delivery and gene delivery. Then they can also be used as antioxidants. So you need not to know how it is happening, you just need to know what applications are possible. Then third point is they can help us in protection against UV rays, ultraviolet rays. They are very harmful, they can cause skin cancers, and they are also components, or they are used in cosmetic industry as well. In addition, they can be used in surface coating material. They can also be used as conducting devices and creation of molecular networks can be another application of Buckminster fullerenes. Okay, so I have given you many examples out of it. Many applications are there. In fact, there are more applications apart from this, though 5-6 points are enough for you to understand. Talking more about the history, in 1996, in fact, Nobel Prize was also given for the discovery of fullerenes, and the people behind this discovery were Sir H.W. Kroto, there was R.E. Smalley and R.F. Curl. You can start your introduction with this kind of statements if a question came up in mains, let us suppose. And students, if we talk about other allotropes, so the next example here is carbon nanotubes. A topic, this particular topic is important because the question has already been asked. I will show you the question at the end of the slides. So students, carbon nanotubes, what are these? These are basically family of fullerenes. They're basically the part of the family of fullerenes only, and they are of varying physical and chemical characteristics. They have very much varying physical and chemical properties and characteristics. These are basically tube-like structure. They can be hollow tube-like structure. They can also be ellipsoidal structures. They can be caged structures or tubular, as I have told you. And they are actually closed graphite structures, right? And I'm just telling you the characteristics. These can be asked in a potential statement form in UPSC prelims. They basically have very much varying physical and chemical properties. I'll give you some examples. The example is that they conduct electricity. They conduct electricity and heat. They are good conductors of heat and electricity. Next point is that they are almost 100 times stronger. And if I'm telling a comparison, telling about the comparison, they are 100 times stronger than steel. So you can see the particular aspect about carbon nanotubes, how stronger they are. Then students, next example is that they can be useful in the cancer treatment. So when we say they are useful in cancer treatment, this particular statement, it was asked in the previous year question, and yes, they can be, because they can easily penetrate. They can easily penetrate through the cell membrane. So if there are any kind of cancer cells, we can actually deliver the drugs, and target delivery can be done at a specific cancer cells and avoiding the degradation of the healthy cells, right? So students, these are the aspects. Apart from this, they can also be used in solar cells. They can be used in transistors, and in fact lightweight boards making as well. So this is an example. All these things can be done using carbon nanotubes. Coming to the next example, graphene. What are graphene? They are basically one atom thick layer. That is why we call them as 2D structures. But you see, one atom thick, so much thin they would be, and that is why they are basically the strongest and thinnest material. So we can use such material, and because of its property it can be used in number of places, it can have number of applications, students, but it is one atom thick, right? And it is one of the, I've already told you, allotropes of carbon. You already know what is allotropes. Another point is that it is most reactive, hard, and helpful in conduction of heat and electricity. The efficiency can be increased if a product is made up of the graphene material. And one such example, if I give you, in making LCD screens, LED screens, there is a usage of graphene as a component, right? Talking about the applications of graphene, there are various applications actually. First point is they can be used in biomedical science. For example, they can be used in analysis of DNA base pairs. This can be one of its applications. Second is it can be used in integrated circuits. You must know the applications of graphene as well, because carbon nanotubes application have been asked, and they can be used in optical electronics as well, plus in filters that are being used for desalination technique, they can be used there. Another application is they can be used in energy storage devices. Apart from this, next application can be in solar cells and also as antibacterial property. So since it has a antibacterial property, many sheets can be made, and these sheets can be used for, sheets of graphene can be used for packing food. This way we can say that there are many applications of graphene as well. And now I want you to understand what is the flow of the research actually. So students, if I just clean the slides, so I've talked about graphene. Now let us say how the nanotechnology approach has been changed from time to time. Till 2000, if we say, the approach was actually of passive nanotechnology. Passive nanotechnology. Stating examples means passive. What actually it means, we were using nanotechnology applications for things where it was not directly or actively involved, like in aerosols, like in coating. So indirect applications were there. But till 2005, what we started active nanotechnology, nanotech applications were there. For example, like targeted delivery of drugs, research happened in this aspect, and maybe, and also in bio devices, making bio devices. Coming to 2010 till here, we now what in the field of biotechnology overall, I am saying the shift occurred, and systems of nanotechnology, systems of nanosystems were created. These systems of nanosystems means that the different forms of nano components, they are bring together, and now the unique applications started growing up, the research in the areas. For example, 3D networking or robotics field. Here we can see many applications, and by 2015 and 21, if we take this duration, we are more focused also in a system of nanosystems, where the wide applications, wide horizons are there. For example, we are focusing on by designing new functions. So now we are focusing on the creative aspect also. Creativity has moved up and now we are designing products. What kind of new products, creative products can be designed using nanosystems? So this is what the approach in the field of nanotechnology throughout the world has occurred over the period of time. So students, till here we have finished about the allotropes of the carbon. We have done the history of the nanotechnology and also understood the basic reasoning like quantum size effect, what is happening at the nano level. So just take a scale. This is a scale, and at this scale you will be much better, you will be in a better position now to understand nanotechnology. Like as a human, we say that 1 meter long is a human, so a hand is of almost 10 centimeter. Our red blood cells are approximately 5 to 7 micrometer. So 5 to 7 micrometer means 7 into 10 to the power minus 6 meter. And coming at this aspect of HIV virus, what is the size of the virus? How bigger is the hemoglobin molecule or a glucose molecule? Here we are talking about nano level, where 10 to the power basically minus 9 meter into 10 is the size, it is the size of a hemoglobin molecule. And you see, when we talk about hydrogen atom is much smaller, and here the alphabet written is 1a dot. What do you mean by this? This is basically angstrom. This is another unit beyond much smaller than nanometer, and that is 10 to the power minus 10 meter. Okay, so we are at this scale, and when we are dealing the material at this scale, we are talking about nanotechnology. And henceforth there are many applications of nanotechnology. Now we will start dealing with the applications of nanotechnology one after the other, whether it is medicine or biology, whether it is environment, industry, agriculture, even we will also discuss regarding electronics. Even I will also talk about space. I will also talk about its application in energy efficiency. So let's move on to the topics where the application aspect needs to be focused in detail, because in UPSC 2020 there was a question regarding the applications of nanotechnology in the field of health, and a specific application was asked. Tomorrow that question can be changed to the applications of nanotechnology in agriculture, or maybe applications in the environmental protection, or maybe a holistic question. Overall question can be asked, a general question can be asked, state the applications of nanotechnology. So now you will quote examples from all the fields. Right, students? So understand, in mains answer also you can expect a question out of it. So do not ignore the topics. Individually also prepare, holistically also prepare, and then henceforth frame your answer accordingly. So the first topic of discussion is in the field of medicine, what are the applications of nanotechnology? I'll give you a few examples and you can use and quote these examples in the exam directly. For example, we can use nanotechnology in the field of diagnosis. We can also use drug delivery vehicles. Now, what do you mean by drug delivery vehicles? Let us suppose these are cancer cells. This is a cancer cell, and these are normal cells. This one is a cancer cell, green color one. You want to give this drug, this particular drug you want to put into the body of the patient. Generally what will happen, that this particular drug will go to the normal cells also and also to the cancerous cells. This is how our healthy cells will also be impacted, or maybe we can say the effect will be seen on the normal cells also. This is how the immune system will be compromised for a person, or maybe the healthy cells will also be compromised. But what will happen when we will use nanotechnology? Students, again I am making the same diagram. This is a cancer cells, these are normal cells. So there would be some kind of receptors on the cancerous cells, and if we take carbon, or we can say nanotubes, some kind of nanotubes are taken, we can tag chemicals. Chemicals can be tagged on these nanotubes, and there may be some kind of a receptor present on the nanotubes as well, and these receptor, they will combine to the cancer cells only, and they will transfer these kind of drugs into the cancer cell only and not our healthy cells. This is why our healthy cells can be protected. So if you're taking medicine, general medicine, all the organs will be impacted. But if you want to give this particular medicine to the specific organ only, maybe you want to take the medicine only for the kidneys, only for the heart, then a specific organ, a specific tissue of the body can be, the drugs can be delivered there, and whole body will not be affected, and henceforth we can minimize the side effects of the system. So this is one such good example of, in the field of medicine, what nanotechnology can do. So it can destroy the cancer cells and without harming the healthy cells. One such example is nanomissile also. Nanomissiles, a group or mass of the nanoatoms, and they can actually do this. These nanotubes can do this. Nanomissiles can do the delivery of the targeted drugs. Another example is repairing of the damaged tissue. If the tissue has been damaged, these nanoparticles can help in repairing of the tissues as well. And you can see there are nanobots. These nanobots are also very useful. These nanobots can reach a specific place in the body, and they can even help in the repairing of the tissue. And these particular nanobots, they can repair the cells also, they can repair the tissues also, they can help in building vessels also, repairing blood vessels also. Anything is possible with the nanobots. If we talk about other applications, there are applications about nanochips, where nanochips can be used to check the plaque in the arteries. So arteries are blood vessels, and if these blood vessels are there, the cells would be there inside. But if this artery is somewhere blocked, it is blocked because of the deposition of fat, or maybe blocked because of the deposition of the calcium ions, then this particular blockage will be called as plaque. And these nanobots or maybe nanochips, they can reach here and they can actually clear the path. So that is why we are saying these nanochips, they can help in checking the plaque in the arteries. There can be the use of diabetic pads. Diabetic pads can help in regulating the blood sugar levels. So you know, if a person is having diabetes, then the sugar level will rise if he or she will be taking a lot of sugar. So keeping a check of it, diabetic pads can be there, and these diabetic pads made up of nanomaterial can also keep a check on increasing blood sugar. Another example, these nanoparticles, drug delivery to the brain for therapeutic treatment. So it can be brain, it can be heart, it can be kidney, any organ can be there, and therapeutic treatment would be there, the targeted delivery of the drugs. Nanosponges, if we say that in our body there are many toxins and these toxins needs to be removed. So what we can do, we can simply send some nanosponges, and these sponges, we are saying sponges because they will absorb all such kind of toxins, attach it with them and then come out of the body. Nanobots, I have already explained, specific drug delivery, they can be used. Apart from this, there can be multifunctional therapeutics application. I have given you example of cancer already, and minimizing the risk of attacking to the healthy cells. Apart from this, there are, if there are fertility issues or brain issues, I have given you example. Here also nanotechnology can help us. Then there is something called quantum dots. These quantum dots, students, they are made up of silicon or cadmium, and they are semi-conducting nano crystals that can enhance biological imaging for medical diagnostics. So these quantum dots, let me explain quantum dots. They are simple silicon and cadmium nanoparticles. They are just semiconducting nanocrystals, and yes, if there is some kind of a diagnosis needs to be done, where a specific diagnosis for a specific region needs to be done, then such particular quantum dots can help us in the diagnosis. And medical diagnostic is very much important, because early diagnostic can help a patient to recover better. These are the applications of nanotechnology in medicine. This question was asked, and if you attempted, or maybe you will attempt the question as a practice question, you have to give these examples. Even if you give 5 examples out of all these, it would be considered as a good example, because in that particular time zone when you are attempting the question in the exam, you tend to forget such examples. Practice it hard so that you instantly remember such examples. Coming to the topic of agriculture and food industry, what are the applications of nanotechnology? So you see, there can be sensors. Sensors can be used for any purpose, basically, not just in the field of food industry, but can be field of other industries as well, energy, environment, anywhere. If I am taking any kind of specific nano sensor, then it can help us, particularly in food industry. If I would say, it can help us in understanding and eliminating the products which are contaminated. Like for example, that in case of presence of bacteria, if somehow the flash of light happens where there are 10 boxes, and out of this one is glowing, that means the sensor is there, and this sensor is readily able to emit light, maybe, or maybe able to change its color in the presence of bacteria. And as a distributor, you, or the food production unit, you will be able to understand that these particular, out of these boxes, this one is contaminated. So this can be the role of easy detection of the contaminants in the food. So nano sensors you must know. Then another is antimicrobial packaging. We can use, I've already told you, some kind of elements or atoms like zinc, calcium also, they can be used so that they can kill the presence of bacteria if it is there in the food. So the longevity will increase, and the expiry date will actually increase, and the product will be safe for further use, and its duration will be increased. Then there is something called nano enhanced barriers. Why not to create some kind of a barrier for the food that is basically being somehow overripe because of the oxygen sensitivity. Let us suppose there is some kind of a food. Let's suppose there is a meat, raw meat is there, and it needs to be transported. And while doing so, you want to keep that food fresh. So in that case, oxygen sensitive food can be with its presence in the air. There can be some kind of a coating of nanomaterial, nanoparticles, which may act as a barrier so that the oxygen present in the air may not impact the particular food and keep it fresh. Nano encapsulation means that it can improve the solubility of vitamins and antioxidants. If we coat a particular vitamin or mineral with a nano coating, so encapsulation means we are coating it and then you are taking it. So the dissolvability or solubility of the particular product will increase because of the nano coating outside. That's it. So these are the 4 examples. Coming to the 5th example is nanobarcodes. These barcodes can be used to trace the outbreaks, to trace the individual products, and maybe even if there are 100 products, 100 packages are being transported from one place to another, these barcodes at the nano level, they will be difficult to read first of all. So there will not be any kind of a leakage, and this is for the security purpose also can be used. And this is how we can ensure that if a particular can, if a particular product is being damaged, So we can also understand this, and then emulsions, they can help us in killing the bacteria without harming the plant. So let's say this is a plant and some kind of a infestation happen, infestation of virus, infestation of fungus, it can happen into plants also. And within the soil, what you are doing, you are putting emulsion. You know emulsion? Emulsion is basically two liquids when they are mixed together. So emulsion is there where some kind of nanoparticles are there. What they will do, they will be absorbed by the plants. They will go to the specific regions of the plant, leaves, shoot, system, or any other part of the plant where the infestation has happened, and it will kill the particular organism, even not harming the whole plant. So this can be one example. And nanocapsules, they can be effective in herbicides, chemical fertilizers. The particular plant, the absorbability will increase because of such kind of nanocapsules. So there are various examples, students. I have made this particular flowchart for you, and you can also draw this flowchart in your exam, where you can mention nanosensors, you can mention nanofertilizers, nanopesticides, herbicides, fungicides, water management can be there, soil management can be there. You can check, keep a check on the nutrient aspect of the soil and what is the basically the fertility of the soil. You can keep a check. You can keep a check on the amount of water that needs to be given to the particular field, and to keep a check also, and if it is increased, it can be absorbed by nanosponges again. So there can be some kind of a material which can absorb the excess water, or there can be some kind of a material which may release the water, right? So these are the examples. Another example is for increasing the food color. This is with respect to agriculture. I am talking about food processing or food industry. And you can just talk about these examples alternatively, because specific if it's specifically not asked. Food color, or maybe the food taste or flavor, can be enhanced using nanoparticles. Another example is the nano size powders can be used to increase absorption of nutrients. So in the soil, with respect to this example, in the soil you can increase the absorption of the nutrients using nano size powders. You can also use these kind of nano size powders so that in your digestive system, when you take such kind of a product, food product, it can be readily absorbed by the cells. Right. So these are the examples, students, with respect to the food industry and agriculture. I hope you understood it well. Coming to the next application in the field of electronics. You know, in the field of electronics, there are various devices, and these devices, their size may be a question. Their size needs to be minimized, and this is how where the role of nanotechnology comes in. So already computers, the chips that are being used, they are at the nanoscale. If we talk about nano chips, Intel is a company that makes many chips. So earlier it used to make the I series. You know, there are many laptops that are coming in the I series, i5, i7. In the I series, they used to actually make chips of 65 to 45 nanometer. But over the period of time, now they are using nano chips of basically 22 nanometer, and this is the huge, basically what? It is a huge research, and huge money definitely would have been invested in doing so. But this is one aspect where the size of the instrument, size of the chips can be reduced, and the data can also be increased. Many such applications are there. So I've already told you the integrated circuits in the transistors, we can reduce the size of the product overall, and for that purpose you can use nano transistors, right? Nano transistors, this is one example of the chip. Then display screens, electronic devices also, display screens can be actually improved. I have told you about graphene, how the example of graphene can be used in LCDs and LED screens for enhancing the picture quality. Then ultimately you can help in electronics, the field of electronics, nanotechnology can help in reducing the power consumption, weight of the equipment, thickness of the equipment, and all such electronic devices which are being in a huge demand because of all these new technologies coming up. Nanotechnology can also have potential roles, and this is an example of nano chips, right? In fact, this is a bigger chip. Many small chips are also being made at nano level. Students, apart from this, there is example of morph device. I'll give you the example of morph device that can be asked in prelims. This has been made by Nokia Research Center. Nokia Research Center and University of Cambridge, okay, of UK. So this device is called as morph. Many applications are there. First of all, what's characteristic it has, it is basically of hydrophobic in nature. That means it is water repellent. Second is it is dirt repellent as well, and it has the capacity to charge itself. If such properties are there, then definitely they can be used in the electronic devices, because we need such devices which are water and dirt repellent and having a capacity to charge itself. You know, very devices are there, electronic devices, if they can charge themselves, it is of great importance to us. Apart from this, there can be manufacturing of e-papers using nanotechnology. There can be displays on sunglasses, and also there can be production of nano batteries which are rechargeable. So it is so important that they can be charged again and again. It will be useful for us to make good mobile phones maybe, and also other forms of electronic devices. This is the example for electronics basically, students, but I give you example of computer science also, that what are its applications in computers. So one such example is of nanorods. These nanorods can be used for display techniques, for future technologies, in future such kind of technology, for consuming less electricity. So this way our computer systems, if they in office there are hundreds of computers, hundreds of people working together, then efficiency of the system will increase and the electricity will be less used. Then there can be transistors. These transistors, in these transistors, carbon nanotubes can be used. Carbon nanotubes can be used and replace the silicon transistors. Silicon transistors can be replaced. In addition, students, there can be nano wires that can be used. These nano wires coated with titanium dioxide can be used for the memory devices. So if there are memory devices, what we can do, we can enhance the memory of the device by using such kind of nano wires. And Intel is one of the examples where I've told you that Intel, it is trying to increase the memory and using more efficient nano chips, right?